Hey, so you want to make a game in Unreal Engine. In this video, we'll cover how to make a simple catcher game with a little twist. This game lets you control a cube with your mouse and block oncoming enemies. We'll use the blueprint system to create the game using just a handful of nodes to create gameplay. In around an hour, we'll go over how to make a character controller. We'll make enemies that use a super simple AI command to run across the screen. We'll make game rules in a game manager blueprint. We'll make blueprint interfaces to make the pieces of the game talk to each other. And we'll make visual interfaces using the UMG widget system to show our lives remaining and our score. I go over all the steps and show you really handy shortcuts so that we can make games even faster. This is an incredibly practical game. I should know because I used this exact code, the code that you'll see me write here, for a game. This tutorial was actually recorded live while I was writing the code and developing it into a game for Takahata 101. You can check out that game in the link below. This is a highly edited video of real development, which is great. We'll run into problems and we'll fix things. If you get stuck, let me know in the comments. But for now, let's focus on making a really simple arcade catcher game. So let's start up Unreal Engine. This project should work in any version of Unreal Engine. So if we go into games here, and then we find our blank project, we can just use this, and this will work perfectly. But I'm going to start with just the blank. I'm actually going to show you in just a moment how even if you forget to bring in the exact preset that you want, you can still import the content from one of these packs by adding a content pack. I'll show you that in just a second. For project details, we want blueprint, we want to keep things at desktop, at maximum quality. You can include starter content if you want to, up to you. Feel free to call the project whatever you like. I'm going to name mine Blocker Game. Don't freak out if Unreal hangs a little bit on the loading screen. Sometimes it'll get to around like the 45% mark or something and it'll just kind of get stuck for a minute. This is totally normal if you're doing this for the first time. When you first set up Unreal Engine, it has to do a bunch of shader math, and it only has to do this once. Unless you have to reinstall an engine or a new version, this won't really happen again. All right, so we have this default scene, but it's not great. So go up to File here and hit New Level. And then we're going to select Basic. Now, one thing you'll notice is that I've changed the color of the tiles. You totally don't have to do this. If you want to, you can click on it, and then you can just double click over here on the material instance, and then you can change the colors over here after you've checked them on. For me, it makes the floor a little bit nicer to look at because you'll be seeing a lot of it during the rest of this tutorial. One of the things you're going to want to do immediately is go to File and go to Save Current Level, and it'll prompt you to put it somewhere in your project. You'll notice immediately that Unreal Engine really doesn't like any kinds of spaces or special symbols in between things. Just name it whatever makes sense to you. Now, one of the first things you need to know in Unreal Engine, basically whenever we want to create something new that lives inside our content browser here, which is the home of all of our stuff in Unreal Engine, we need to do a little right click. We do a right click and it brings up this menu. Now there's a lot of things here, and most of these are different kinds of assets that we can create in Unreal. Some of the more important ones are up here, like blueprint classes, which are all the important little pieces of functionality that we're going to put inside the game. This makes all this stuff happen. Levels, as you've already seen, are these, are levels. It's kind of easy. And materials, like we've already just discussed here with our background. And Niagara systems, which are particle effects. We're not really going to worry about those here. Now, I can also add a feature or content pack. So if I go up here, I can actually find some of those presets that we looked at before, but we didn't add. So I'm going to go to this third person one here, and I'm going to go ahead and add it to the project. So even if we forgot to add some of this content when we were first making our project, we can grab it now. If I had chosen to start our project using the third person character template, I would also start each level by using the third person character. Now we're going to be using some of the content from this pack later. However, we're not going to be using it as our main character. We're going to be creating a new one from scratch, called Blueprints. Now I'm going to go make a new Blueprint class. And I'll have a bunch of default stuff here. But because what I'm making is so different, I'm just going to make an actor. And I'm going to sort of wing it. So I'm going to call this BP underscore player blocker. We actually need to make another blueprint first to be able to control the character. We're going to make a player controller blueprint. So we're going to make another blueprint class. I'm going to grab player controller. I'm going to name this BP underscore mouse controller. Let's hit Control S to save so that asterisk goes away. In order to implement this mouse controller, I'm going to need a game mode. Make another blueprint class, go with game mode base. I'm going to type in BP underscore blocker game because I'm feeling so original today. And for our game, we can access our class settings, go to our class defaults here, and over in the corner here, basically what this does tells Unreal, hey, I want to control what gets spawned in, including the controller. So we're going to take that player controller class, and then we're going to grab it right here. So our BP mouse controller, going to grab that. And then we're going to save this, and then we'll go back to our settings, and we're going to go to our project settings, and then we're going to go to maps and modes, and then we're going to grab our default game mode, and then we're going to grab blocker game. So when we press play, typically this will spawn in a player controller. I'm looking over here over on my sidebar, and I can see actually, yes, actively spawned a blueprint both for the blocker game and for our mouse controller. Let's open up our mouse controller and just ignore everything that's here for now. We're going to go over here, back to event tick. Okay, so I'm going to pull this out here, get, hit, result, and you'll see, first off, it's not really coming up, even though we're in the proper place. Once I change things from being context sensitive, for whatever reason, then I can find what I'm looking for. So now that I've got this, I should be able to get a hit result. And this will figure out where the cursor is in relationship to the screen. And not the screen specifically, but the world around it. If I pull this out, I'm going to turn context sensitive back on. I'm just going to type in break. And I'm going to break the hit result. And this is a common block that you'll see for different kinds of hit results. Hit results are anytime we ask Unreal to detect whether or not something is colliding or two things are running into each other or something like that. So this is pretty common in game development. I'm going to grab my location, and then I'm going to promote this to a variable. I'm going to call this mouse location. There's a possibility that my mouse won't hit in the scene, which would be weird. So I'm going to branch this here, type in branch, that'll pop up, plug these two in. So now that we have this mouse location, I need to kind of manipulate this. However, I can do all that stuff inside our character. So I'm going to go back to our player blocker here, add the blueprint into the level. This is really important. The only gameplay elements that are going to run in the level are the ones that are in the level. So make sure to add it in. Click here on BP player blocker. It's underlined, looks like a hyperlink. I'm going to open our player blocker. Currently, he's got nothing going on and no data. He doesn't know where to go. We already have an onTick function running, so I really don't want to use his onTick. So what I'm going to do is I'm going to create an interface. Interfaces are great. There's just basically, simply put, one way for blueprints to talk to another. So I'm going to make this blueprint interface, and I'm going to call this main, or BPI underscore main gameplay. So we know it's a blueprint interface. Control S to save. It'll start me off with this new function. I want to call this update location from mouse. And then we're going to grab inputs here, and I'm just going to grab the vector and change its name to mouse location. So that comes up very nicely. If you capitalize new words, you'll find a little space in the middle. Now I need everything to subscribe to this main gameplay in order to send information through it. Kind of like how I need you to subscribe to my YouTube channel. It's such a terrible plug. I'm really sorry about that. I'm gonna go back to my player here, and then you'll notice that I don't have any way over in the sidebar here to be able to hook this up. So I'm gonna go to class settings, and then I'm gonna go over here to interfaces, click. So I'm gonna type in main gameplay, pops right up, it's easy. Now if I double click one of these things over here, I'll get this new event that happens whenever this gets called. So now that I have this event, I have a place where I can send that mouse data. I'm gonna go back to our mouse controller, and then in the event that we have a hit return, we're gonna send the mouse location data, and we're gonna send it over to our player blocker. So what we're gonna do here is we are gonna look up our player blocker. So we're gonna get actor of class. And we know there's only ever going to be one player blocker in the scene. Player blocker will be the one that we want, and then we'll have it. However, this happens every tick. We don't want to look through all of our actors to find our player blocker every single time. So I'm going to snap this by pressing Alt and clicking on it. And I'm going to move this up back to event begin play. event begin play, get actor of class, player blocker. And I'm going to save that as a variable. Put that to variable. I'm just going to call it player blocker. We can now take our player blocker. We can get a reference to it. We can use our interface to talk to it. So we're going to send player blocker mouse location. And you want it to say message in parentheses. And the mouse location sent over to our player blocker. That means that this event here will also fire, which is sent through the interface. So a big problem we have right now is that our player blocker doesn't have any physical object. We have a scene root, which gives it a location, but it doesn't have any mass. So I'm going to go ahead and just make a cube, and then I'm going to lift it up here. Then whenever this fires, we want this to go where the mouse is. So let's set actor location, and we're going to leave the target as self. So that's us. That's going to be right here. And then the new location is going to be what we just got from the mouse location. So we're going to save this. And if everything's working correctly, when I play this, we're going to have a moving cube that kind of flies into the screen. Now, what's going on here? What is this? So what's happening right now is that our mouse is hitting the cube, which is also an object in the scene. So it's teleporting on top of itself a bunch of times in a row, which is pretty goofy. And I don't know, maybe you want to make a super broken game. Now we'll go back. We need to figure out something in our mouse controller. We need to make sure that we're ignoring certain actors. So I'm going to pull up hit actor here. I'm going to type in get class, and I'm going to make sure this isn't our player character. So I'm going to go not equal. We're going to make sure it's not equal to our actor. And that's going to be the player blocker. We're going to make another branch. Let's move this out a little further here. And now, if we're not hitting the player blocker, we're not going to move anywhere else. Now, I think we're going to have another problem in just a second here. Let's tease it out. All right, so let's try again. We'll play. And this works. But if you noticed, our movement's a little bit jumpy. Basically, we're never moving and we're never firing unless we're touching the ground. So we need a more organic way to be able to avoid having our cursor interact with this. So I was able to fix this problem by changing the kind of hit scan that we were using. Instead of the hit result for the cursor by the channel, which is just visibility or camera, I wanted to filter it by object types. So I know that the floor is going to be a world static object, so I made an array here, which you can do really easily just by dragging out and just type make. And then world static comes up by default. Also, just double check, make sure that's the case. Click on your ground here, and that should be static, not stationary or movable. If the object is world static, then we know for certain it's not going to be our actor, which is a world dynamic object. That being done means that we'll have a really smooth mouse flow. However, this is kind of a weird game, right? You'll notice when we click in on it, we also have this problem where we're moving and we're moving the camera at the same time, which is sort of a problem. So we're going to do a couple things here that will help a lot. Because this game happens in a fixed perspective, we're going to just use a cinema camera as our game view. I'm going to grab a cinema camera out, and I'm going to snap object to view, which means it's loosely getting our view right now. Now, cinema cameras are really fun, but they also can be kind of funky with focus, because they have focus. I know a lot of people don't like depth of field in games, but in a game like this, I think it'll be pretty rewarding to see. To make sure that our focus is always correct, I'm going to type in focus, and I'm going to change it from manual to tracking. And for tracking, I'm going to grab an actor to track, and I'm going to select our player blocker. That's good. Let's go back to our mouse controller. So currently at the beginning of the game, we're grabbing our character and our reference to it. Now, let's do something else right afterwards. I'm going to control click to bring this over here. I pressed S to make a sequence. You can press S while clicking to make a sequence. It's really great. You can also just go in here and type in sequence, and I'm going to plug these together. So the first thing that'll happen is we'll find the get actor of class. And the next thing that's going to happen is we're going to set our cinema camera as view. So I'm going to get set view target with blend, and I'm going to find a new view target. So once again, we need the opportunity to find something. Before we get our view target, I need to get actor of class. Now, this one's kind of tricky, right? Because we only want one actor to be returned. And there might be reasons for you to have other cinema cameras in your game, which would make this complicated. So a simple trick that you can do is make a custom blueprint. I'm going to go to blueprint class here, and then I'm going to type in cinema camera. So the cinema camera actor comes up. I'm going to select it as the base of my new class, and I'm going to call this game camera. And I already have all of this good work over here. I don't want to get rid of that. So what I'm going to do is I'm going to press Control S to save my game camera. I'm going to right click it. I'm going to replace the selected actors with what you'll see here, the selection, game camera. And this should leave everything the same because they're mostly the same class. There's not much difference. However, we only have one game camera. We're only ever going to put one game camera in the scene. So once we get our game camera, type in game camera, go ahead and promote it to a variable. Control click to drag my stuff around here. I'm going to rename it over in the corner. I'm going to call this game camera. I'm going to pull this into my new view target over here. And the rest of the stuff you can leave alone. There's one other thing I want to do just for safety. And this is because of just default Unreal behavior. But I want to add one more here, and I want to type in set viewport mouse capture mode. And by default, we'll have capture in Unreal. So when we set this up, it should make sure that we're not capturing the mouse directly in the viewport and using it the way that we're using it before. So now when I play, I've got this fixed perspective, and my character goes where I want. One thing you want to do, if you're going to use the cinema camera as a game camera, is you want to turn off the aspect ratio. So if you type in aspect, over here you'll find constraint aspect ratio. If you turn that off, you'll have a much better time when you go to play. So you can see I now have a camera that is like the width of the whole screen. Now you can customize cinema cameras a little bit, which is why I like to use them. To get a better view, we could start messing with the focal length here, which is basically the zoom, or we could just move the camera forwards and backwards or closer to our subject. Go ahead and give it a try and do it to your own taste. Do you remember earlier when we made our game mode? It happened really fast. We made a game mode blueprint, and then we used that and we set it as our default. Now, one thing we have to do is make sure that it's not spawning a pawn. In a typical game, we move around with the WASD keys through a player pawn. Currently, our cinema camera is overriding this kind of thing. However, if I press this little eject button here, we can actually explore the scene outside of any player character controller blueprints. So you can see there's this little orb. Now, this orb might still appear on screen, and we want to make sure that doesn't happen. So we need to not spawn that now that we have our cinema camera in the scene. Go back to the game mode and just remove the pawn. Now, this still doesn't seem like a game. This looks like a tool. So what I want to do is I want to sort of like get this guy to just like stay on this line here. So what we'll do with that is I'm going to take our blueprint. I'm going to move him where I want him here, right? So our default axis is right on this line. So what I want to do is I want to make sure that our player blocker never ends up going anywhere it doesn't want to, where it's not supposed to. So I'm going to make sure that we're only going to use one axis. There's two things you can do. You can split the struct pin. I'm going to press Control Z because what's a little nicer is when you pull it out and you press make vector. And then I'm going to break this because you can break or make. And I'm just going to pick one of these specific axes. We're going to go X, Y, and Z. I'm going to leave those the way they are. And then I'm going to use get actor location. And I'm also going to do a break. And I'm going to use our own values. This is us. This is our actor. So when we combine these, only getting one axis. And you can see this works really nicely. So we can slide back and forth. And we're starting to have the basis of our blocker game. We need to block enemies from getting through. This is kind of weird because it gets out of our viewport zone. Kind of awkward, huh? So I'm just going to make another actor. And I'm going to call this, I'm going to name this BP underscore goalpost. So the goalpost doesn't really have to do much of anything except that just exist. I'm going to place one in the world, and then I'm going to hold the Alt key. I'm going to hold it, and I'm going to hold the other one there. So we need these two different places in the world. So our player blocker is also going to look for some actors at the beginning of the game, because generally we're always going to want to do several things at the beginning of play. This time we're going to get all actors with an S of class. I'm going to call this goalposts. I'm going to bring up our goalposts here, pull this out, and I'm going to type in 4 Now this is very common. What we're working with here is what's called an array. So this is returning an array, which is basically just a list of objects or pieces of data. From the array element, I'm going to pull this out, get actor location, and I'm going to add it to another array. So I'm going to add array. Just type in add array, pull it right up. Got a new array here. Currently it's undefined, so I'm going to promote it to a variable. I'm going to name this goal zones, and then for every one of those, we're going to loop them, and then we have our goal zones here. For this game, we've decided that we're only going to deal with things on the x-axis, right? We're only going to take that x-axis data, and we're going to use that for our actor location. So what I can do with each of these arrays is I can find the maximum and minimum of their x-axis. So we'll leave our goal zones here just in case we need it later. But what I can also do is I can type in break again, and I can break the vector. So I'm going to take the x data, and I'm also going to grab that to an array. So I'm going to name this goal zone x. I'm going to promote this to a variable. So for our goal zones here, we're going to anticipate that there's 2 of them. But what we can do with this specifically, with an array for a float that we can't do for the vector, is we can figure out what's the biggest one. So on our next line here in our sequence, I'm going to come over here, I'm going to grab our array, and I'm going to type in maximum. So we've got our maximum float, and we'll find out what it is. We can also grab the same exact array and type in minimum. And what we can do with this is we can start saving these as values as well. Call this max, promote this to a variable, call this max x, and I'm going to promote this one as well, and I'm going to call this min x. I'm going to plug these both in, and we're good to go. So what we need to do whenever we're transferring our data over here is make sure that we're staying between the max and minimum x. Now we can just do this with math. It's quite easy. So what we're going to do is we're going to type in clamp, and we have a max and minimum. So we're going to make sure that we're never going outside of these. This is really easy because we can just type in, plug in our maximum and minimum. And then we'll never go outside of our 2 little goalposts here. So now we're not going any further than our 2 sides here, which is really great, even if our mouse goes out of it on the other end. And you can see there's little glitches, there's little things that'll happen. Like if the mouse moves off too fast, it's sort of a problem. Obviously, we wouldn't necessarily want the character to be able to move that fast too. So we might want to figure out some sort of deferred system that would move the character over time. But for now, this is fine. So we're going to go back to our third-person stuff, and we actually are going to use third-person character blueprint. So we'll pop this in here, and obviously this character here is like a little bit bigger. So this was the part of the show where I realized we had a little bit of a problem. The only way to proceed here was to do some rescaling. So I did some rescaling. I went back in, made that cube full size, still kept him above the root point, moved the camera out, and I'm going to move our 2 goalposts over here, be in much larger space. In terms of a game like this, where the goalposts actually are is kind of whatever makes you happy. So at this point in the game, what we're expecting to see is the AI walk across the screen and try to get past. So we have these enemies, they're coming through, and they want to get across. So what they need to do is they need to spawn and walk all the way through. Now, luckily, with Unreal, we can kind of just use this default behavior here, and we don't really have to change anything. We can just kind of let this run. I'm going to go ahead and then I'm going to right click and create a child blueprint class. So I'm going to call this BP_enemy. And before I save it, I'm going to move it back over into the My Blueprints page. Similar to the way we had goalposts, we're going to have enemy spawners. So I'm going to make another class here. But wait, I hear you saying, Woody, there already are spawners. You can use the spawner from Unreal. Kind of. There's a lot of default behavior in Unreal that kind of lends itself to third-person games and shooters. For the sake of the argument in this one, just go with me here. We're going to make our own spawners. They're just going to be simple actors. So we're going to call this spawner. We're going to add one in 3 different places. So like one here, and one here. I'm pressing Alt and I'm dragging to be able to move everything. Then I'm shift clicking to be able to select them all, and I'm going to move them back. Want to be sure that they're not in our view when I press play. let's talk about our enemy behavior. Now, there are tutorials about how to set up AI in Unreal, and they're great. Like there's a whole AI system, and it's very deep, and it's worth learning if you're interested in. But there's also this little shortcut called AI Move To that we can use. So it's really simple with our enemy AI here. We're gonna go to Event Begin Play, and then we're just gonna type in AI Move To. It's this little one with the box here. You click on that, and then destination appears. So our destination we know is going to be along the y-axis. So all we're really going to have to do for this is we're going to have to get actor location. It just says, hey, where's our enemy? And then we're going to add a little bit to it. So on our y here, on our y-axis, we're just going to add like 200. Now there's a good chance when I play, the AI will actually go backwards. So if I select this and I go -200 on the y-axis, press save, there's a better chance. We also need to make sure that this pawn is filled, and we're going to grab self. So we're going to get a reference to self. We're going to point that right here. There's one more reason that our AI might not move, and that's because we don't have a nav mesh. We can go to this little icon over here with the green plus sign and click on it. Now this will let us add anything to the scene that already exists as sort of a default class in Unreal Engine. Now, if we move our mouse to one of the options that doesn't have a specific category, we can just start typing and we can look up whatever we want. So let's type in nav mesh. And I'm gonna get a nav mesh balance volume here. And I'm just gonna press the R key for scale. You can also find the scale setting by pressing this little button up here, but I like pressing R because I feel like it's a little bit faster, but not everybody likes using keyboard shortcuts their first time around. And I'm gonna just make it really, really, really big, like a little more than I would necessarily want. I'm gonna go over here to show navigation. And you can see I actually have a show navigation that's up now. I'm gonna go in here and I'm gonna replace the enemy. Let's see if this works. And looks like I'm going the wrong direction. Going back to my enemy here. I'm going to change this -200 back to my first guess, 200. And we should have something that works now. So the AI takes a couple steps forward and stops. So 200 is not going to do it. So what we need is more like maybe even 16 just to be safe. Now we're going to put him over on a spawner. And you can see the enemy runs by. Now we can still could move our view out just a little bit more. And we can include more here, stagger them a little bit. But the idea is we want to stop them from getting through. It looks like we could go even further. So like a good 2,500. Your mileage will vary. So you have to make sure your nav mesh is big enough. Otherwise, the space that you told them to go to, they might be like, I'm not sure there's room for me to go there. So we'll make sure that it's corrected. And then you want to stop them. So a couple things need to happen for our core gameplay loop to be able to stop these enemies. So our characters will rush across. They need a goalpost to get through to. And our little box also needs to be able to destroy them. What we'll do here is we're going to have some functionality in here. So for collision, this is going to be called event hit. Basically, this will say, hey, am I running into another actor? So on hit, we're going to break the hit result, and then get class. So we're going to drag that out. We're going to get class, and if the class is equal to the player blocker, then we'll be able to destroy it. Press B and click, or type in branch to find a branch node, and also search destroy actor. This will destroy the enemy blueprint that we're editing inside. Let's see how that goes. Boom, 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 got him. Now, it can be kind of fun to watch them stop. So I'm actually going to add a little bit of a delay. Type in delay here. I'm going to add like a half a second to watch them kind of come to a stop first. Later on, maybe we'll add some visual effects or something when we actually make this a real game and we do art and stuff. But for now, I just want just the little effects. Just kind of fun. We're also going to grab our AI Move To, I'm going to grab that in the self, and I'm going to press Control to grab the other part of it. You can copy and paste with Control C and Control V, or you can press Control D to just duplicate. So that once it gets stopped, it's like it's done. Can't move any further. This is just a little visual effect. So it's just going to try and be exactly where it is. So we'll save that, and that way it won't look like it's trying to escape even after it's been stopped. Boom, 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 stop, stop, stop. Ha, got him. Perfect. It's great, but it's not quite a game. We need ways to get points or lose lives. One thing I like to do is have one actor that's in the scene that sort of controls the game. I usually call that the game manager. Now, I understand this is pretty common if you're doing like Unity scripts. Theoretically, in Unreal, you could use the game mode base to be able to set up some of this functionality. Personally, I'd rather just make an actor and then have the game mode base spawn it if I want to use game modes to be able to switch what kind of game it is later on. So I'm going to select this. I'm going to call this Game Manager. And what we need the Game Manager to do is continuously spawn more enemies, first and foremost, and then also track what our score is and if we're losing lives. So let's start by making some variables for the Game Manager. I'm going to grab this. I'm going to say lives. I'm going to make that an integer, and then I'm going to make another one. I'm going to call this score. These are both going to be integers. And then also I'm going to make something here called rate, and that's the rate at which they're going to spawn in. And that's actually going to be a float. I'm going to go to the event graph, and then on begin play, I'm going to set up our core game loop here. So I'm going to use a timer. Timer by event is specifically what I want. So timer by event. Drag this out. And then I'm going to make an event here, make a custom event. I'll type in custom event. And I'm going to name this spawn new enemy. And this is going to happen basically every time. A couple other things I'm going to do. I'm going to make sure looping is turned on. And I'm going to plug in the rate here. Now, I'm going to compile this so I can set the rate. And for the rate for now, let's just say a new enemy is going to spawn in every 2 seconds. Nice and easy for now. I'm also going to go ahead and promote this to a variable. This is the timer. This is helpful if later we want to stop it. So let's say the game is over. We don't want to spawn any more enemies. We can also do that through another variable, however. So let's just do that right now, actually. We're going to name this game. And if it's game over, then we're not going to do the current action. We're going to get game over, and then we'll branch. You can hit the B button to create a new branch, which is really cool. Hit the B button and click, and that gets made. So by default, we want to make sure that the game over is false, because on true, we're going to do something cool. So let's go ahead and spawn an actor from class. This is really cool. So we're going to spawn our enemy, BP enemy, and a couple of things happen. First, we need a place to spawn the enemy. But where would we spawn the enemy? Well, we have those spawn points. Maybe we should use those. Let's go back to the beginning, and we're going to press S and click for our sequence. And then I'm going to drag everything around with the control click, and I'm going to find all actors of class. Get all actors of class. And then I'm going to make sure we get spawner. We get our spawner. I'm going to promote this to a variable. So every single time we do this, we want to generate a random number and use it to get the spawner. So I'm going to put our spawners here, and I need to find out how many spawners are actually in here. Theoretically, with the way this works, if you wanted to add more spawners into the game, you totally could, which would be awesome. So I'm going to grab the length of the spawner, and that means how many of these guys are in there. So I'm anticipating 3, right? So I'm also going to want to get a reference or copy. Doesn't really matter in this situation. And then I would need to find out which one, right? So arrays are base 0. So the first item in any array is going to be 0, which kind of changes things, because if you have a length of 3, it means you have 3 objects. So we want to get a random one here. So random integer in range. And from that random integer, we're going to get their spawn location. So first, I'm going to grab the length, and I'm going to go -1, right? Because we want the maximum to be 1 less, because the beginning is 1 less. We're going to go to get actor transform, actually, and we can use that. Now, however, there's a small problem here, because transform includes scale. So typically, what I'd rather do here rather than accidentally scaling something up later, what I would rather do is I'd rather make transform and then get location. And then this should do very nicely. When we press compile, we don't have any errors anymore because we have a place to send our new enemies. And there's a lot you could do here. If you wanted to change what class is going in, you could change different types of enemies. Maybe some of them are faster than others. It's totally open to you. But what should happen now, if we press play, is we should get more enemies spawning in every moment. I'm going to eject here, just see what's going on. Nothing. We don't have them. This is really simple to fix. So make sure your game manager's in the scene. That's the important part. So we'll just put him in here first. So sometimes when we have an issue like this, we need to debug a little bit. We can hop over into the selected over here, and we can kind of see what's firing or not firing. Currently, this is firing, but it's not making it through the game over section here. So our game over is set to false, and we actually want that to be the case. So if game over is false, then we will actually fire all of this information. So now we should be getting some new a new cohort in any second now. Let's see what's happening with them. So they're over here, but none of them have started running yet. That's sort of an odd question. If you find that when you start the game, the AI isn't moving, what needs to happen is they need to have an auto-possess AI when not placed in the world, but spawned. Now you don't want to change that in the viewport. You want to go into enemy here, and then you're going to go to class defaults, and then change auto-possess AI, and then off of spawned. I know it's a little confusing, just hang with me here. So now when we start, we should have some AI just continuously pour in every 2 seconds, and it should just be from a random lane every single time. So let's say we wanted to crank up the difficulty here. We could increase the rate. So instead of every 2 seconds, what about every 0.2 seconds? And now we've got like a, kind of a worthwhile game, and you can see actually it's like kind of impossible to stop them all. You remember how we made that blueprint interface earlier? Well, guess what? We can use it again. We can use it for all sorts of stuff. So this one was for main gameplay. It's just going to update the location from the mouse. I can add another function in here that will indicate something was stopped. So enemy stopped. Or I'm going to go back to my game manager, and then I'm going to go to class settings, and I'm going to give it an interface. So type in main game. It's got that main gameplay now. And I'm going to give it a brand new section. I'm going to go to interfaces. If at first you don't see the correct interfaces loading, that means you need to save the interface, compile it. Save and compile, save and compile. When I go back to my game manager, I'll see that that's there, and I'll grab my enemy stopped function. And for now, I'm going to say that every time we stop an enemy, we're going to get another 10 points. So the score will increase. So I'm going to get the score, I'm going to add to the score, and then I'm going to set the score again. Simple set here. The player will win 10 points every time they stop an enemy. I want to be able to see that the score is being updated, but I don't want to make my user interface yet. So I'm going to go over to Instance Editable, and I'm going to turn that on. I'm going to press compile again. I'm going to press save. Let's go back to the enemy blueprint. I also want to make sure that the enemy is calling that. So before we do our little AI move to stuff here, I want the score to update immediately. I'm going to space all this out. I'm going to call the game manager. Well, we haven't found the game manager. We don't have a game manager yet. Kind of like what we did before. I'm going to press S, do a sequence, and I'm going to find the game manager. So I'm going to get after a class, and I'm going to call game manager. I'm going to promote it to a variable. And that way I have it at the beginning of the life of the enemy. Don't have to look for it at the end when things are the most chaotic. Wouldn't want to cause any hiccups or any frames to drop. So the game manager, I'm going to enemy stopped. I'm going to make sure I get the message version of that. Control grab, bring that over here, and then I'm going to compile. And let's see if that works. So I've stopped a bunch of enemies at this point. The only way to know if things are working is to eject pop out here. I'm going to go into my outliner. If you're in a situation where it's hard to find like this, you can just type it in up top. And from clicking on it, I can see my public value, and I can see that the score is updating, which is great. So let's go back to the enemy blueprint. So we have a score, and it's increasing. Let's set up a life system. When we go back, open your game manager, and let's set the default number of lives. Current is 0. I want to start it at 5. Press compile, and then I'm going to press save. How do we know if we have an enemy that has succeeded? Well, we can make a trigger box, and that's going to help. If our enemies cross through this box, then we will know for certain that they have succeeded. I'm going to make this really, really big. I'm going to press the R key, and I'm going to drag my mouse to scale it out. And I don't think you can be too generous with this. You want to keep this out of the view of the camera. One thing you'll also notice that could be a problem is that you could get, as long as we're changing things over here, you notice how I'm messing up the nav mesh by placing my character here? That's because of the physics type. So if I go into the cube here, I don't want to actually do this in here. I want to do this in my player blocker. I click on my cube, and then I want to go to physics. And block all dynamic is our preset. So we have a preset, but let's change it to custom. And then I'm going to change my object type to pawn. I'm going to turn off this box here that says can't ever affect navigation. This should fix everything now. All right. Now, let's figure out this trigger box. The trigger box, once again, is something that works better if we can put our own code into it. So I'll leave the trigger box in the scene, but I'm going to make another one with its own blueprint class. I'm going to make my own version of the trigger box, not because I want to put code in it, although I could, but because it'll help me figure out if I have that type of actor later on. So I'm going to call this for enemy win zone. So I'm going to go back here. I'm going to take my trigger box. So you can do it in the outliner, replace it selected with enemy win zone. Now that the trigger box is custom, this enemy win zone here, we can go back into our game manager, and we're going to need another interface to be able to use here. This is going to decrease our lives. How would we do that? Well, we're going to use another interface. I'm going to call this enemy 1, another event, and our game manager is going to have that set up. Make sure to save and compile. And this time, we're going to just remove the number of lives. Now, we could press plus and or minus, actually, decrease the number of lives, and then save it. Or I could show you a cool little trick here. Default with Unreal is this little macro called decrement. So you decrement int, you just plug this in, and this will update the number of lives. And I want to do a little check every single time this happens to see if so many enemies have crossed over that we've actually died. I'm going to press B and click to bring up another branch. I know it's sort of an advanced shortcut. We've done it a couple times, but I think it's pretty neat. And then I'm going to bring back my lives again. Probably also just use the decrement. And I'm going to ask, is it less than or equal to 0? If it is, then we have died. So for now, we'll just print we died. So we have to make sure that that works on the enemy side as well. So we can get actor begin overlap here. Actor begin overlap happens. I want to see if this is a trigger volume, but specifically the class, specifically our kill zone here. And then let's find out, see if it's equal to our enemy win zone. We'll wire that all up. So we're going to grab that game manager again, and then we're going to send enemy 1 as a message. Then we're going to delay for a few seconds and delete the enemy. We'll give them 2 seconds and then destroy them. Let's go back to the game manager. So if we press Control D, we can bring over this print string. In the event that we didn't die, let's just program it to say ouch. That means we're alive. After we die, it won't say ouch anymore. So now we get all these ouches, and then after 5, we're dead. So let's make a custom event for death. Right-click and search for Add Custom Event, then give it a name. At this point, this is getting a little shaggy, right? So we might want to add some comments. This would help. Enemy stopped, enemy cleared, or enemy won. So I'm going to make this the spawn system over here. Name it spawn system. A number of things will happen after we're dead. You can do a little alt click to snap lines between nodes. We need them again. They're right there. Type in, we died, because that's our custom death piece here. First thing that happens when we die is we're going to set the game over. Save that. And once that's on, that means we'll no longer start spawning new enemies. So we're going to stop a bunch of them here. And then at some point, we're going to get that game over. It's just going to happen. So you see, we got like all of those enemies stopped. Other thing that we're going to do is we are going to have all of the existing enemies on the field stop in place as well. I'm going to create a new custom event here. I'm going to call this stop. And I've actually kind of already programmed this in a little bit. So I'm just going to save us some time. I'm going to press Control X, Control V for this new stop function. We can call stop and keep on moving. I called it a function, but it's actually a custom event. Fun little fact, you can press the Q button. You can straighten out nodes. You've got them all selected. And the stop basically just makes the character stop in place. Very simple. Back to Game Manager again. In the event that there's a game over, we're going to get all actors of class. We're going to get the enemies. And then we're going to make another for each loop here. I'll plug that in. And then we're going to ask them all to stop. You may be asking yourself, if you're really paying attention, like, hey, Woody, why are you not using another blueprint interface here? Well, you don't always have to use them. Sometimes it can be a little bit tedious. It's always a best practice, but sometimes you're just like, okay, I have something that's not super important, and I know it'll work just the same way if there's any enemies on screen. Later on, when we start doing art, we could make the remaining enemies that haven't crossed the finish line do the Fortnite dance. But for now, the Fortnite dance. I am officially 40. Cool. So this will make sure that we don't spawn any more enemies, and that we will have the other ones that are still going stop so they don't end up getting hit and killed. Also, we want them to become impervious. So I'll show you what I mean. So we have all of these crossing, and eventually it's like, hey, well, they won. Well, what happens if one was standing like right on the line and I was able to kill him during the game over? I also don't necessarily want to move the cube. So I want to do two things. I'm going to create a state of imperviousness for enemies. So I'm going to make another branch here. The enemy's impervious. We don't have to worry about it. And then we'll just promote this, and I'm going to call this killable. Compile this and make sure it's set to true. Our gameplay manager, when this happens, we want to make them all not killable. So we'll set killable to false or not checked, and they'll all be good to go. If you get an error, just save and compile. I also want the player to stop moving, which means I want to be able to cut off the motion controls. I want to do that at the character level. So I'm going to get the player block. And you see how the line of code we have that moves the player? Well, it's really easy to interrupt this. We just do another one of these. Press B and click or look up branch. And then if it's true, then we're going to set the actor location. And if it's not, we keep moving. If it's not game over, we're going to keep the location here. So we're going to promote this to a variable. I'm going to call this game over to match the other one. You're going to want to make sure this is off by default. And for this one, I want to use another interface. Because this is a bigger kind of gameplay event, I want one that I can use in multiple places. I'm going to find the latest interface. I'm going to add that to the scene here, and then I'm going to use this to turn on our game over. You'll notice that we got a little 0 here. Unreal Engine added this, probably because we already have a value called game over somewhere else. The game manager also needs to be able to talk to our character. So I'm going to go back up, and I'm going to add another line. Press Add Pin to create a new line on our sequence. Maybe actor of class So get actor of class. This is going to be player blocker. I'll promote this to another variable, and I'm going to call it player. It's another thing we're going to do in our list here. So we're going to affect all of the enemies this way, but we're also going to affect the player. I'm going to grab the player, and I'm going to send him blueprint interface. Game over. And this time I don't have the message. So what you can do here is you can turn off context sensitive. Sometimes it just goes away for some reason. And you can send game over message. Let's go back to our player blocker blueprint. Otherwise you're gonna have a problem here. You can understand the basic logic. You want the default state to be always firing the actor location. See? And that's how we have a game over. Make sure you save your level. We have a working game. This is awesome, but there's still a little bit more left to do though. We can't see any of the information on screen. We don't have any lives on screen, and we don't have any sense of our score. So let's just take a minute and make a rough user interface here. User interfaces can be as simple as or as complicated as you want. For right now, I'm gonna try and keep most of it complete within like 2 different blueprints. So we're gonna call this UMG for Unreal Motion Graphics. We're gonna use the user interface system for widget blueprints. So I'm going to just create a generic one, and I'm going to call this game screen, no spaces. Let's call this WB underscore game screen. Going to open that up. All right, so I'm going to start by making a canvas. I want to talk a little bit about these for a second. So a widget blueprint is essentially a flexible amount of space. Right? So you can move it to any different screen size, and that's what's kind of important about it. So what can be tricky, though, is to figure out how exactly you put your UI elements into the screen if it can be any size. So I'm going to say I want my lives on the left side and my score over on the right side. I don't know why that is, but I'm just gonna say that for now. The easiest way to do this is to start by using canvas panels. So I'm going to drop some canvas panels inside canvas panels. You're going to see that this gets confusing in a second, but we'll just try and go through it as simply as possible. I'm going to kind of space these out and like use the visual editor here, and I'm going to find like a suitable amount of space. I'm gonna do that. I think that's good. And then I'm going to grab this other one, and I'm going to change its anchor point. So I'm going to change the anchor point to be over on this side of the screen. And then suddenly we have like a different starting place for this canvas panel. I'm gonna like line it up, see if I can get it to be a similar size. This one's for our score. If I use the shift key, I can drag it out. I'm gonna call this our live zone or lives panel. And I'm gonna continue to set the stage here. So this canvas panel is actually not what I want to hold everything. So you can see if I stretch everything out, I've got weird amounts of weird stuff going on with my shapes. I started at like 720p, and that's kind of funky to me. So we said this one would be our score. Scores are really easy. We can just use text. So we'll find text, pop that in here. And to make this fit well, I'm gonna wrap it in a horizontal box. So I'll go wrap with, horizontal box. There's nothing magical about wrap with. It's just the same as grabbing a horizontal box and putting it in here. Just a little bit more convenient after we've already put something in. I'm gonna make sure that we have all the room we need in here, so we're gonna go fill the horizontal box. Currently everything's scaling wrong, and it's because I just need to scale out the horizontal box. I want it to be the same size as the canvas, so I'm gonna make the anchor the entire canvas and then set all my stuff to 0, 0 here. I set everything to the middle here. That's how we're gonna have like a decent score system. If you're worried about the score going too far, you could just write justify, and that way if it's like a million, big million, it'll just keep going that way. Worth noting that some things will scale well and some things won't. All right, that looks good. You want to scale things constantly to make sure it works. Let's go to a 1080p monitor situation here. This is simple enough. You can actually just leave it like this, and it's totally fine. And over here's where we have our lives. Now the lives are a little bit more complicated. I want to grab another horizontal box over here, and I want to drop it in. Once again, I want to make it the whole size of the anchors. So I'm going to zero everything out after selecting the full size anchor. I now have a horizontal box, and I can start putting some lives in here. Now, we could just use some images, but let's say actually we want to get a little bit fancy. We can make another widget. We'll call it user widget, and we'll call it lives. Let me draw a heart real quick in Photoshop. This is actually not Photoshop, it's MS Paint, but you can use any image anywhere you can get a PNG file. I'm gonna grab my heart, I drop it in here, and I'm gonna use this heart very simply. I think I can just drag and drop it in here, and it'll make an image. So now when I go to this palette box up here where we can find a bunch of our widgets can also hold our custom widgets. So let's look up our WB Life. WB Life. I can add it into my horizontal box and you'll see what happens. It doesn't look great. It's kind of stuck. We're going to add some padding. Start by like 2, maybe 10. And I know you screaming internally. It's like, Woody, no, that looks really weird. Hey, how about this? How about that? Is it better? There we go. We'll just change the alignment settings. Gonna maybe do a little bit less of that. And then suddenly we have something that's much more palatable. So they look small now. Let's see if we can fix this over in the widget editor. I'm gonna take this image and I'm gonna wrap it with a size box. We're gonna do some overrides here. As you can see, we can use this size box to really change things. Let's go with 230. Now we go back to our game widgets. It's a lot better. There we go. Some nice little hearts. And if we want to add more, watch what happens. We press Control D to add another, and they keep getting added in a predictable way. Some might say that having that many actually wouldn't be good. So maybe we want to change our horizontal box to a wrap box. This would help a lot with something like hearts. So I made a couple changes. I went back to our size box inside the WB Life widget and I changed it to 75. And I also added a padding to the image itself, so that way we would always have a decent amount of padding around the edges. So you can make those changes as well. Widgets get a little bit complicated. They're one of the more confusing things in Unreal. Now, this is going to be surprising, but we're actually going to get rid of all of these. And I'll tell you why. I'm going to make this wrap box a variable. I'm going to call this life container. I'm going to go back to our game manager blueprint. I'm going to make a new event called evaluate lives. I'm going to make a custom event. I'm going to grab the lives here. I'm going to put this into our chain. In order to send an evaluation over to our HUD system, you guess it, I'm going to need to talk to our character controller. And we haven't touched the character controller in a while at this point in the tutorial. So I'm going to go back into my blueprints, my character controller. Before we go any further with our linking things together, I'd like to make sure that it adds in our HUD in the first place. So on begin play, we're going to still do everything else we're doing here. And then I'm going to create this line that says create widget. So it's going to make a widget. We're going to use our WB game screen. And then here we're going to add this to viewport. Let's see if this is working. When we start the game, we should see it. You can see our score in the corner. And that's really good. We just died. Before we're finished here, we want to add this as a variable. So we'll call this HUD widget. Save that. We'll have our game manager go looking for it. Our game manager is going to, I'm going to insert an execution pin here beforehand. This is going to be one of the first things it does. It's going to find our player controller. Now it doesn't actually have to find the actor class. It could just say get controller and then grab get player controller. Considering this is a one-player game, player index 0 will work perfectly fine. I'm just going to grab that and I'm going to promote it to a variable. I'm going to call it controller and I'm going to save it. So when we're evaluating our lives, I'm going to grab the controller. I'm going to cast to mouse controller when this happens. so that I'm going to get it as a mouse controller, because the mouse controller has the widget that we want. It has the HUD widget. Let's get to get HUD widget, and we're going to add another interface. We're going to call this update score lives, and we're going to cast to that from the widget. So update score and lives, which is fine as long as we remember we still have to give it the widget. And you might be thinking, oh, Woody, where am I even going to put that widget? Oh, well, no problem. If we click on the graph button up here, it takes us to the widget graph. Now, every widget is its own blueprint. If we go to the graph page, we can mess around with all the different components the same way as we would with any other blueprint. We can switch back by clicking back on the designer page. Go to class settings and add your interface. So I'm going to add this here, this update score lives, but currently doesn't have any information in it. So I have to go back to my updates again. I'm going to need 2 integers, lives and score. Now, if we save it, it should update everywhere, and we can now enter information into the fields. Let's go back to our game manager. So we're going to give it the current lives and the current score. In fact, we could just rename this. We'd evaluate lives and score. We want to call the exact same argument after an enemy is stopped. Now we can add a bit of programming to our main game screen. Now, some of this stuff is very, very easy. To change this text, we just need to make it a variable, and I'm going to change the name to score. If I go to the canvas panel, I've already made the wrap box a variable, and I've called it life container. Let me go back to my graph again, and you can see that they show up now as variables. The score is really easy, so we're just going to grab the score, and then we're going to set the text. Super simple. And then we'll just grab the score. However, for the lives, things are a little bit more complicated. Now, the life thing is going to seem a little weird. So the first thing we're going to do, get the life container. I'm going to make a local variable over here, and I'm going to say, call this widget lives. I'm going to connect it here, using control click to be able to move my little strings very happily. When the widget lives changes, we need to know. So when the lives first come in, we're going to see if it's different than the widget lives. And if this is equal to widget lives, then you don't really have to do anything later on. I know I'm sort of tracing back over myself with all of the different strings here. Thanks for sticking with me. I'm going to add a branch node here by pressing the B key and clicking, and I'm going to connect the socket. Now I'm going to do something that's really clever here, and this is something I really like about coding and blueprints. So in either situation, I'm going to update the score to the current score, because that's really easy to do. If the current number of widget lives is equal to our expectation of how many widget lives, then we can go ahead and just resave the value and move on. If, however, they're different, that indicates that we lost a life or something. So we need to change it. I know this is a little complicated. In that case, we need to actually change the number of lives. What we're going to need to do is we're going to need to clear the life container and populate it. Get life container, and we're going to clear all the children. After we've cleared it, we can add back the accurate number of lives. So we'll take this new number, and then we're going to drag up. I just double-click to be able to create this reroute node, if you're wondering what I'm doing. And then I'm going to write a for loop. For loop is a first index and a last index. We talked a little bit about indexes before. We'll change the first index to 1, because that's how many lives we have left. It starts with 1 and ends with the last of how many that we have. For that, however many times, we're going to take our life container again, drag it out, and then we're going to add widgets. Type in add child. In order to create something for the add child, we're going to have to create a widget. That'll come before it in the node chain. So we will add lives approximately however many times for however many we have here. And this is really great because we won't have to subtract or add every single time we lose or gain a life. Each time, we will add the exact number of lives that we need. However, we're not done yet. Once completed, we need to set the score and set the number of widget lives to the number that is expected so that next time the same thing functions and runs. And as you can see, it seems to be working pretty well. There's only one main thing still left to add, and that's a game over screen. Go back to our main game screen, and then I'm going to add a game over sequence. I'm going to add another text, and I'm going to parent it under the main canvas. I'm going to make sure he gets anchored right in the center. I'm going to set all of his positions to very low amounts, 100 by 100 size. And then for alignment, I'm going to put it all at 0.5. You can kind of do this to taste depending on your font and how you like it. Game over. Lastly, you won't see any of the animation controls just lying around, so I need to add a few. Animations are up in the corner here. I'm going to call this game over. And I'm going to track in text. I'm going to give it a little bit of a transform. Stretch that over a couple frames. I pull this down, and then I've actually got these reversed. And you can see that stays right there. Game over pops up. And also add an image. More to the top, I think. And we'll make it cover the whole screen. We're going to add the image. Set the color and opacity. The alpha down here, or the A, determines the opacity. We now have a game over. Now, let's just add a visibility track to each of these. And you'll see why in a second. I'm going to make these invisible by default. Now, if the lives equals 0, which is logic that we'll add to the end of this chain, we can copy over some of this stuff with Control D. And if it's equal to 0, the new amount of lives, then we will trigger the game over animation. I'm going to drag it in here, animations underneath our variables. We're going to play animation with finished event. I don't know what you want to do once it's done, but that finished event can help a little bit. And we'll just grab a self reference to this blueprint. We'll just add that extra bit of logic. Now, this is definitely spaghetti string blueprint, but we're trying to work fast here. There's only so much I could fit, in a given amount of time. So let's see if that works. There we go. And that's a working game right there. Now, there's a bunch of things we could do here, right? We could increase the rate to add difficulty to the game. We could add an environment. We could make new levels. Play around with it. Add more to this thing. Thanks so much, and I hope this helped. If for some reason you're having trouble, let me know in the comments.